Sorry. Sometimes school network is not working. It's what is the results? Yeah. Am I audible here? Am I audible? Yes, sir. Okay. Are you able to see the screen?
Yes, sir.
Screen? Good. Now listen. Here we'll see the anomalous behavior. Anomalous behavior, or you can say different, different behavior, different behavior of lithium and beryllium. Children, listen. This lithium and beryllium shows the different behavior. You can see the lithium. This lithium, this lithium and beryllium shows different behavior in their own group. In their own group, like lithium react with hot water. This lithium react with hot water, but sodium react with cold water. Sodium react with cold water. Lithium react with hot water. Okay? You can see that in group number 1, alkali metals, lithium, sodium, potassium, rubidium, cesium, francium, they all are brothers, and that lithium is younger one. And you know, if 5-6 brothers are there, तो सबसे ज्यादा किसको रिस्पेक्ट मिलता है? छोटे वाले को मिलता है, और छोटा वाला जो है बहुत ज्यादा बदमाशी करता है बड़े के कंपेयर। अब लिथियम कह रहा है कि हम गर्म पानी से ही नहाएंगे, और सोडियम पोटेशियम क्या कर रहा है कि ना ठंडे पानी से भी रिएक्शन करा सकते हैं। इट मीन द सोडियम, व्हेन यू पुट सोडियम इन कोल्ड वाटर, so obviously it will react with water and release hydrogen gas. So sodium is highly reactive with respect to cold water, but lithium is not. लिथियम ठंडा पानी से डर रहा है, लिथियम करा ना आपको गर्म पानी आप देंगे तभी हम रिएक्शन करेंगे। सो लिथियम शो द डिफरेंट बिहेवियर इन देयर ओन ग्रुप। लिथियम हम ये पढ़े हैं कि दैट ऑल द एलिमेंट ऑफ द सेम ग्रुप दे हैव सेम प्रॉपर्टीज, बट lithium show the different behavior. Lithium, you can see hydroxide, lithium hydroxide is weak base, whereas sodium hydroxide is strong base, potassium hydroxide is strong base. So other members form strong base, their hydroxides are strong base, but lithium hydroxide is weak base. So see that why there is dissimilarity in the properties. Same, the compound of lithium, like lithium chloride, lithium carbonate, lithium chloride, lithium carbonate. So when you see, all are the covalent compound and they are insoluble in water. But when you talk about the sodium chloride, potassium chloride, so this is ionic compound. Ionic compound. But the lithium compound is generally covalent and insoluble in water. So lithium compound, most of the lithium compounds are partially soluble in water, but the other members compounds like sodium, potassium, their compounds are readily soluble in water. So why this lithium show the different behavior? This lithium is showing different behavior. All these are the different behavior. That is called as anomalous behavior. So the question comes that why lithium show the different behaviors? When we talk about the beryllium, so itself beryllium has many dissimilarities with other members of one group like magnesium, calcium, strontium, barium, radium. Like beryllium oxide, when we talk about beryllium oxide, so this is amphoteric in nature, but magnesium oxide is basic in nature. So beryllium oxide, amphoteric, magnesium oxide, basic in nature. See that it's a different behavior. Why it is? Beryllium form polymeric structure, but other members cannot form. Beryllium compounds are most covalent compound and they are insoluble in water, but magnesium, calcium, strontium, other compounds, the compound of other metals are highly soluble in water, but beryllium compound is not. So why this beryllium shows the different behavior from their own members? Why this lithium show the different behavior in their own members, in their own group? Why? So the question comes, So the reason is only three reasons. The first reason, second reason, and third reason. The first reason, they are smaller in size. Smallest means smaller in size. And second reason is absence of d orbital. Absence of d orbital. There is no d orbital in second period. You know, first period has only 2 electron. Second period has only 8 electron. So for 8 electron, only S and P is sufficient. So the second period, in second period, there is no d subset. So absence of d orbital is also a factor to show the d similarities in their own group. Now, third reason is high polarizing power. High polarizing power, like due to the smaller size, they have high tendency to attract the electron of other atoms. So polarizing power, high polarizing high polarizing power, like when we talk about the lithium, sodium, potassium. So due to the smaller size of lithium, it has high polarizing power, means it has high tendency to attract the electron of other atom also. Clear? So the power of cation or the power of metal to withdraw the electron of other atom is polarizing power. Clear? So due to the smaller size, this lithium has or the beryllium has high polarizing power. So there are three reasons: smaller size, absence of d orbital, and high polarizing power. Due to these three reasons, they show different behavior. Lithium and beryllium, they show different behavior, which is called as anomalous behavior. Am I clear? What are the anomalous behavior? So anomalous behavior is the first. Anomalous behavior is the second one. Anomalous behavior is the third one. The first one, lithium reacts with hot water, other member react with cold water. Second anomalous property, lithium hydroxide is weak base, whereas other hydroxide like other metal hydroxide is strong base. Sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, they are strong base. Third anomalous property is what? Lithium chloride is covalent and insoluble in water, but other member, form their chloride, which are ionic in nature and they are readily soluble in water. So these are the different key similarities in the properties of lithium with other metals of the same group. And what is the anomalous behavior of beryllium? So beryllium oxide is amphoteric. Other oxides are basic. Beryllium, you can say, form polymeric structure, and whereas other members form, they don't form any polymeric structure. Just wait, beta. Okay. Just I will take few minutes to stabilize the internet connection. Yes, yes, and just
Sir, your voice is not audible.
Okay, I think now it is audible. So, due to these three reasons, uh, lithium and beryllium, they show different behavior. So they are showing the different behavior, that is called as anomalous behavior. I hope now it is fine, clear, all these 3 points. Yes, tell me yes, yeah, no.
Yes.
If no, so I will do means revise it. Okay, Pratyush, thank you. Next, next topic is what? Next one is diagonal relationship. Diagonal relationship of lithium and magnesium. Now see, in the case of second and third period beta, everyone see, in the case of second and third period, just a minute. In the case of second and third, okay, in the case of second and third, it's a second period. See that this is a periodic table, and this is the second period element beta. See that this is the second period element. Second
Sir,
period,
your screen sharing is paused.
second period
Yes,
element.
sir.
Okay. Again, I will share the screen shares. Don't worry. Okay. I hope now it is fine.
Yes, sir.
Okay. Thank you so much. Now see, in the second period, all these are the second period element. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Clear? And now this is the third period element. It's a third period element. Sodium, magnesium, aluminum. Third period element. Yeah. Third period element we have, just a minute. Third period element. Third period element. We have third period element, sodium, magnesium, aluminum. So what we will get, that the lithium is diagonally related with magnesium because of same atomic size. When you go left to right, so you will get that the atomic size becomes similar to the third period element which are diagonally related. Atomic size of boron is nearly the same with silicon. Atomic size of carbon is nearly same with phosphorus. Nitrogen nearly same with sulfur. So atomic size, you can see atomic size, you will find out the similarities, and due to having the same atomic size, their periodic property will be same, like electronegativity, electron gain enthalpy. So if they will show the similar properties, so this relationship is called diagonal relationship. So generally the elements of the second and third period, see, suppose second period element, we have second period element, lithium, beryllium, boron, carbon, nitrogen, oxygen. And the third period element is sodium, magnesium, aluminum, silicon, phosphorus, sulfur. So when you go left to right, So atomic size increase or decrease? Tell me. Yeah. When you go left to right in the same period, what will be the atomic size?
Sir, decrease.
Very good. Thank you, Abhishek. So atomic size will decrease. See that when you go from lithium to beryllium, atomic size will decrease. Atomic size will decrease. Atomic size will decrease. Atomic size will decrease. Fine. And when you go top to bottom, like second to third period, atomic size increase or decrease?
Increase.
Increase.
Increase. Thank you, Sneha. Atomic size will increase. So suddenly atomic size will increase. And again in the third period, if you go right side, so again size will decrease. Size will decrease. Size will decrease. Size will decrease. And size will decrease. So what we will find that the resultant size of lithium and magnesium are similar. Size of beryllium is similar with aluminum. Size of boron is similar with silicon. Size of carbon is similar with phosphorus. Size of nitrogen is similar with sulfur. So if they are having the same atomic size, so their periodic property will be same. So in the case of same periodic property, they will obviously they will show the same chemical property. Clear? So the element of the second period, they show the similar property with the element of third period diagonally. This relationship is called diagonal relationship, and why they show same properties? Because of almost nearly the same atomic size. Clear? Because when you go left to right, atomic size decreases, but suddenly top to bottom increases, but again left to right decreases. So increase decrease will be balanced diagonally in the case of second and third period, not in fourth and fifth. This relationship you will not observe in other periods, because this you can say that the resultant increase decrease cannot be balanced in all cases. Only this is present in the second and third period. So this relationship is called diagonal relationship. It means lithium will show the similar property with magnesium. This lithium show the similarity with magnesium. Beryllium show the similarity with aluminium. Like beryllium oxide is amphoteric, aluminium oxide is also amphoteric. All have studied in class 10th that aluminium oxide is amphoteric. Beryllium oxide is amphoteric. Lithium react with hot water. Magnesium also react with hot water. What are the diagonal relationships of lithium? So diagonal, diagonal, diagonal relation of lithium with magnesium. So diagonal means similarity. You have to discuss the same property. And anomalous behavior में different property you have to discuss. So here that the lithium as well as the magnesium both react with hot water. Both react with hot water. गर्म पानी से reaction करते हैं. This is the similarities. Lithium hydroxide is weak base. Similarly, magnesium hydroxide is also weak base. दोनों के hydroxide हमारे weak base है. Lithium as well as magnesium both form hydroxide which is weak base. Fine. Now, lithium as well as magnesium, their compounds are generally covalent and compound insoluble in water. Partially soluble in water, insoluble in water. Most of the compound of lithium and magnesium insoluble in water, insoluble in water. So these are the dissimilarities. Sorry, these are the similarities, which is called as diagonal relationship. So why this lithium show the diagonal relationship with magnesium? Because of having the same atomic size. Now, what is the diagonal relationship of beryllium with aluminum? So diagonal relationship of beryllium with aluminum. So here the point number one, beryllium oxide as well as aluminum oxide both are amphoteric in nature. Both are amphoteric in nature. Second point, this beryllium as well as aluminum both form polymeric structures. Polymeric structure. Polymeric structure. Polymeric structure. Like say, suppose this is BeCl2. So in the case of BeCl2, you can observe that one molecule of BeCl2, this is BeCl2. This is another molecule of BeCl2. This is third molecule of BeCl2, and they will help together with help of this intermolecular force, which is called as van der Waals force. Van der Waals force. So this is called as van der Waals force. This is polymeric structure where two or more molecule of BeCl2 are held together. So that is called as polymeric structure. Same aluminum chloride also form polymeric structure. How it is? So you can see aluminum chloride AlCl3. AlCl3. So in the case of Al, you can write ClClCl. Same you can write AlClClCl. Same you can write. So you can see that how the one molecule is interacted with other molecules. So this is called polymeric structure. So in this case, you will observe that the molecule will be Al2Cl6. Al2Cl6. So this is polymeric. So just like the beryllium, aluminum also form polymeric structures. So these are the similarities. These are the similarities. You can see that these are the similarities, so which is called as diagonal relationship. Any confusion? Any confusion about diagonal relationship?
No, sir.
No? Clear?
No, sir.
Very good. So if you want, take a screenshot and share in the chemistry group at least. My photo will come at least.
Sir, remove the pop-up of the markers, please.
Okay.
Sir,
Yes.
sir, slight little bit of.
Okay. Thank you, Abhisar. Yeah. That is fine.
Yes, sir.
Yes.
Good. Have you noted? So this is about the diagonal relationship. Hmm. And anomalous behavior. So also take a screenshot of this one. This is about anomalous behavior. Take a screenshot. So how you all are feeling at home? Good or not good? The coming school is good, I think. Hmm? Note it. If anyone just take a screenshot of this one and share in the chemistry group, at least. देखिए कौन पहले भेजता है 1 2 3 Yeah, share in the chemistry group. Take a screenshot. क्या चलता है क्या वो थोड़ा चलेगा देखो जेपी सर इज हियर at least taken class. Okay, okay. We all are also enjoying children. Fine. Oh, personally भेजा है. Good. Thank you, Digyansu. Thank you. Yeah.
My pleasure, sir.
Abhisar has also said very good, Abhisar. Thank you so much. Yeah, recently content. Oh, please be share कर दिया ठीक fine thank you now yes yeah now tell me any confusion doubt because only 1 year 2 minutes is left है ना in the class after one we have time 5 to 6 minute time acha we have completed this one so obviously we'll see the ncrt exercise question of the same chapter there are total 45 or 46 strength but out of them all these 15 students are honest and they are ready to join the class good now we'll do the ncrt question Anna, at least I have completed this entire chapter and even I recorded the video. So I will share this video in the class group. Fine. Now we'll do some NCRT questions. NCRT question. How we'll see the NCRT question? देखते हैं. Periodic classification. Periodic classification NCRT. Everyone just open your NCRT book and see the 3.1. चलो मुझे तो याद है NCRT. तुम लोग देखो अपना 3.1. In 3.1 you can see 3.1 it is written देखो एग्जाम्पलर 3.1 मेरे पास तो देखो भाई एनसीईआरटी तो मुझे याद है एग्जाम्पलर सो आई डोंट नीड बुक बट यू शुड आई थिंक एग्जाम्पलर में द क्वेश्चन नंबर 3.1 so in 3.1 I think you have to write IPSC name of element having atomic number 120 IPSC name and the symbol. So symbol will be what? Symbol, tell me anyone. Symbol of 120, atomic number 120. For one के लिए what we will use? For one के लिए what we will use? Tell me. Un. Very good. U. And two के लिए pi P. And zero के लिए nil N. So the that symbol will be un UBN एंड आईपीएससी नेम क्या इसका बन जाएगा बेटा IUPAC आईपीएससी नेम हो जाएगा अन बाई और जीरो के लिए नील और लास्ट में सफिक्स लगता है IUM अन बाई नीलियम दिस इज द आईपीएससी नेम एंड द सिंबल विल बी UBN 3.2 एनसीईआरटी एग्जाम्पलर 3.2 क्वेश्चन नंबर ठीक है चलो अब 3.1 है सर 3.2 कोई बताएगा टेल मी 3.2 बताओ 3.2 क्वेश्चन नंबर 3.2 क्या कह रहा है 3.2 3.2 कह रहा है कि पीरियड 5 है n is equal to 5 so tell the possible subcell how many possible subcells are there and possible subcell and not possible subcell possible element how many elements are possible I think in period number 5 so we know period number 5 so period means principal quantum number so here the principal quantum number is 5 given so if n is equal to 5 तो l is equal to 0 से लेके n minus 1 0 1 2 3 4 ऐसे लिख सकते हैं now if l is equal to 0 so this indicate s subcell this indicate b subcell l की value 2 indicate d subcell l की value 3 indicate f subcell here and 4 में G सबशेल. So we know that the G subshell is not possible. ये एग्जिस्ट ही नहीं करता है. अभी जो आपके पास पीरियोडिक टेबल है उसमें G कहाँ है? only 4 blocks are there, S P D F. और बताओ 5वें पीरियड में F ब्लॉक किसमें चालू होता है? F ब्लॉक किस पीरियड में है? F ब्लॉक आई थिंक छठे और 7वें में है. 5वें में F ब्लॉक भी नहीं है. F ब्लॉक भी नहीं है. नॉट पॉसिबल. बताओ कितने एलिमेंट बन गए? कितने सबशेल है? SPD1. SPD पॉसिबल है तो इसमें 2 इलेक्ट्रॉन, इसमें 6 इलेक्ट्रॉन, इसमें 10. मतलब टोटल कितने हो जाएंगे? टोटल 10 और 6 और 2
सर
मतलब 18 इलेक्ट्रॉन. यस बेटा.
सर आपका स्क्रीन शेयरिंग पॉज हो गया है.
तो टोटल 18 एलिमेंट्स आर पॉसिबल. अच्छा ठीक है, अगेन आई एम शेयरिंग. अच्छा नाउ टाइम इज ओवर. चलो अगले क्लास में मिलते हैं, है ना. अभी मीटिंग एंड होने वाला है. 11 बजे मिलते हैं आफ्टर ब्रेक. 11 बजे मिलते हैं तो फिर विल डिस्कस. थैंक यू सो मच. यू ऑल कैन लीव द क्लास.
यस सर.
You all can leave the class. Thank you so much.